Okay, perpendicular and parallel lines. So if we have two lines, y equals to ax plus b, and we have another line, y equals to cx plus d. If we know that the two linears are parallel, we must say A equals to C. If the gradient not equal, they cannot be parallel. In other words, if they want to be parallel, the gradient must equal. And if we know A equals to C, then we know if we draw those two linears, the two linears must be parallel to each other. And the similar thing happens to perpendicular. If we know the gradient times together equals to -1, we can say the two linears are perpendicular to each other. If we know that they are perpendicular, you must know the gradient times together give you -1. Okay, they can go both ways. Okay, so that's the concept. Okay, very simple, only 4 lines of this exercise. Okay, now I want to decide if the graph of each pair of rules will be parallel, perpendicular, or neither. Okay, so we have 2 lines, and we only need to care about the gradient. If we know the gradient of both lines, we can say it's perpendicular or parallel, or neither. So what's the gradient for the first one? The gradient for the first one is a half. Okay, what's the gradient for this one? This one will equals to 2yx plus 5, and y equals to a half x plus 5 over 2. And the gradient for M2 equals to a half as well. Okay, I cannot see the gradient in the general form 2y minus x equals to 5. I must make y to be the subject and see the gradient. And we have M1 equals M2. So they are parallel. Okay, if the gradient equals, and you can say the lines are parallel. For the next one, we have gradient equals to -3 for the first one, and gradient equals to a third for the next one. They're obviously not equal, so we will try to times them. So it's -3 times a third, which will give you -1. So, perpendicular. So they're perpendicular to each other. The times together must equals to -1, and they can be perpendicular to each other. It's 3x plus 2y equals to -5, and x minus y equals to 2. So 2y will equals to -3x minus 5, and y equals to -3 over 2x minus 5 over 2. For this one, y will equals to x minus 2. You can move y to this side and move 2 to this side. So y will equals to x minus 2. For the first gradient, I have -3 over 2. For the second gradient, we have 1. Now we can see M1 definitely not equals to M2, and we can try to times them, and if you can see they're not equals to -1. So not parallel or perpendicular. Not parallel or perpendicular. Okay. Example 2. Find the equation of the line that is parallel to y equals to -2x minus 7 and pass through the point 1 and 9. Okay, so you know there's one line already, and you want another line which will pass through the point 1, 9 and also parallel to the first linear. So now what we will know, this is finding equations for linear, right? Finding equations for linear. So what we can know is the gradient equals to -2 for sure. The gradient equals to -2 for sure because it's parallel. And the second thing, we know that it passed the point 19. Okay, we know the gradient and we know the point that the line passing through. Okay, so to find linear equations, we think about two things. First, do we have gradient? Yes, we have gradient now. Second thing, do we have the y-intercept? No, we don't have the y-intercept here. Therefore, we need to use this formula, y minus y1 equals to mx minus x1. Okay, if it's yes, we use y equals to mx plus c. Y equals to mx plus c. So y minus y1 have y minus 9 equals to minus 2 x minus 1. Okay, y minus 9 equals to minus 2x plus 2 and y equals to minus 2x plus 11. Okay, that's example 2. Let's have a look at example 3. In example 3, I want to find the equation of the line that is perpendicular to y equals to 3 minus 5x over 7 and pass through the point 59. I want to ask, what is the gradient of this linear? Sorry? Minus 5 over 7. Thank you. So if you can separate that, is 3 over 7 minus 5 over 7x. Okay, so if you still consider, I'll make minus 5 over 7x plus 3 over 7. You can make that to the standard form. And the gradient equals to minus 5 over 7. Okay, so that is the current, already we exist one line here. And I want a line where perpendicular to that and also past the point 59. So what the gradient should be for the second linear? What? Yeah? 7 over 5, thank you. So we have the second line, will have gradient of 7 over 5 because I want the two gradient times together to have -1. Okay, you need to have the negative reciprocal. Negative reciprocal. Okay, you change the denominator and numerator and you take off the negative sign or you put on the negative sign. It's negative reciprocal. So they are negative reciprocals and also they pass through the point 59. Okay, we know two pieces of information here now. Do we know the gradient? Yes, we know the gradient. Do we know the y-intercept? No, we don't know the y-intercept. So we will use y minus y1 equals to mx minus x1. So y minus 9 equals to 7 over 5x minus 7. And y equals 7 over 5x plus 2. Oh no. Okay. Number 4. Okay, if you finish number, I will give you some time to finish number 3. And think about number 4. Okay, think about number 4. What is different comparing number 3 and number 4? Yeah. So we cannot find what? Yeah, yes, the gradient. Thank you. We only have x equals to 3. That's a vertical line. And we don't know the gradient. But we want to find a parallel line. So if it's a vertical line and the line parallel to that, that will become a vertical line as well. Okay, it's another vertical line. So I want a vertical line that will pass through the point 6, 1. What that line should be? X equals to 6. Okay, good. So if you have difficulty to see this, okay, I have a point 6 and 1, which is here. Okay, I have a point 6 and 1, which is here. I have x equals to 3. X equals to 3 is here. That's x equals to 3. And I want a line parallel to that and pass through the red dots. So I will have this line passing through here. So the x value is 6. So this line will just be x equals to 6 will be the answer. Okay, if you can see this visually, we have a vertical line and we need another vertical line to have those two lines be parallel to each other. This vertical line must pass through the point 6, 1, which means the x value must be 6. Then I have this linear x equals to 6. Okay, this one compared to the first one, the previous two was quite easy actually, but you just need to see it. We cannot really write what is M1, what should be YM2, but we need to see it in the graph. Okay, example number 5. Find the equation of the line that is perpendicular to x equals to 7 and pass through the point 1.5 and 8.4. So x equals to 7 is a vertical line. If it's perpendicular to that, I will have a horizontal line. If it's a horizontal line, it will be y equals to something. And it passed through the point 1.5, 8.4, which means the y value equals to 8.4. I will have a line y equals to 8.4. Again, if you have difficulty to see this, I would like to draw this for you. We have 7. Okay, that's xy. That's x equals to 7. I have a point at 1.5. It's here, 8.4. Which is here. That's my 1.5, 8.4. I need a line which is perpendicular to that. I need this red line. Okay, I need this red line. And this red line pass through the point 1.5 and 8.4. We have a height of 8.4 here. So it's y equals to 8.4. Okay. For the last example, we have find the equation of a line that is perpendicular to y equals to mx plus c and passes through a, b. Okay, it's no numbers. Okay, it's literal equations. We only have letters in it. So we have the first equation is y equals to mx plus c. Okay, tell me what the gradient should be for this equation. M. Okay, so what's the gradient should be for the next equation, next line? It's parallel. It's perpendicular.
Negative 1 over m.
Negative 1 over m, yes. So the gradient should be negative 1 over m because that times m will give you negative 1. Okay, so I have the gradient. And what's the point I know? I know a point that the line passes through is a, b. Okay, point a, b. Have this point. And next, what we can think about is, we know the gradient. Yes, we know the gradient. Do we know the y-intercept? No, we don't know the y-intercept. So we need to use y minus y1 equals to m times x minus x1. So y minus y1, what is y1, which is b, equals to the m. M is the gradient. The gradient is minus 1 over m times x minus the x1. x1 is x. Okay, so I can write the equation in this way. So y minus b equals to minus 1 over mx plus a over m. Y equals to minus 1 over mx plus a over m plus b. So the y-intercept is actually this. Okay, the y-intercept is actually a over m plus b. That's the y-intercept. But it's looking for the equation, and that is my equation. Even though it's all in letters, it doesn't really matter. Okay, letters can represent numbers. Y and x are the variables, and m and a, b, they are the constant. They are the constant. Okay, so this exercise is actually connected to the previous exercise. Okay, it's connected to the previous exercise. Is how to find linear equations. It's still to find all kinds of linear equations. And we just need to know the gradient is not directly given to us. It's tell you or parallel or it's perpendicular to something and ask you to think about what is the gradient. Okay? Okay, so have 5 minutes left. You can finish up the notes, or you can do some book exercise, or you can just rest for a while, prepare for the next lesson.